Hi, we are continuing with building models, and this is problem number 2. It is labeled number 8 on the worksheet. So you have a nice little diagram given, and it describes a rectangle that is inscribed in a semicircle. And so it shows you how the rectangle touches the circle at the 2 points, and then otherwise it is a rectangle. It gives you that this point is point P, and that is x comma y. And then it asks just for a few things. So the first thing is for part A, it asks us to find the area of the rectangle as a function of x. Okay, so just the area of the rectangle part. So in other words, the shaded part here only. Now, hopefully you remember that the area of a rectangle is just the base times the height. Okay, so we just have to figure out what the base is and what the height is. And let's take a look. Since we know that this is point P, okay, is x comma y, we actually know what that means. The x coordinate goes from the origin, 0, 0, over to the x coordinate. So this would be x right here, just from the origin over to the point, and then it would go up a length of y. Okay, that's what this x comma y is telling us where to go on the rectangle. Okay, then we can tell that this side is doing the exact same thing by symmetry. So this side is also x, and this side is y. This point is actually at negative x, right? But the distance here is x, because distance is always positive. And then this is a rectangle, so the same thing would be happening up here. This part would be x, and this part would be x. So the base of this rectangle is 2x, and the height of the rectangle is y. So let's write that. A equals 2x times y. Okay, we're not quite done, because what they're actually asking is for the area in terms of x. What that means is, like, write it as a function, a of x, and we can't have y's in here. Okay, we can only have the variable x and numbers and operations. So we already know 2x, and then we need to translate that y into something in terms of x. Well, we actually know. Right here, given in the problem, is y equals square root 4 minus x squared. That's the equation of the circle, but notice that point P is on the circle, so that is the equation for y at that point. So just substitute for y square root 4 minus x squared. Now we have a function for area in terms of x, and we're finished. For part B, it asks us to find the perimeter of the rectangle. Okay, so the perimeter of the rectangle is the distance around the rectangle. If you were making a fence around the rectangle, how much fencing would you need? How long would the fence have to be to cover all 4 sides? So the perimeter of this rectangle looks like there's a 2x, right here, and then there's another 2x on the top. So 2x plus 2x is 4x. And then we also have a side of y and another side of y, so plus 2y. Now we have to do the same thing we did in the other part. We are supposed to be finding the perimeter in terms of x only, so we can't have that y in there. So this is 4x plus 2, and then we know that the y is still square root 4 minus x squared, because the points on the rectangle are based on the circle. So square root 4 minus x squared. There's no need to try to simplify these in any way. They really can't be, and they also look great as they are. All right, so then we move on to part C, and all it wants us to do is graph the area and then find what value of x is A the largest. So we're going to be finding the maximum. Okay, so this is going to be graphed in our calculator. We definitely don't have to graph this kind of thing by hand, promise. Okay, so remember that you go to y equals right here, and then you type in the equation 2, then x. Remember, x is right up here. It has a lot of letters on it, x, t, theta, n. That's a variable button. And then use the square root button, second, and then this button, and then 4 minus x squared. Then you'll hit enter. And then to see this, you're going to want to hit graph. Okay, so you get this cute little curve thing, and you can see it does have a restricted domain and range, and that's because of the square root, right? We can't put anything that would make the number under the square root be a negative. So that's why it's so restricted. And then it said we wanted the area to be the highest. So let's draw this on our paper because we want to be able to see it later. Okay, something like that. Okay, keep in mind that this would be the area and this would be the x. So what we're looking for is the highest area, which would be right here. And that, of course, is called the maximum. So we're going to do what we did in the other problem, and we're going to go second, calculate, and then maximum is number 4. So number 4. And then we have to do the left bound, right bound thing again. So I'm going to go towards the maximum. Notice it's asking for the left bound. So I just need to be to the left of it. And now I need to go past the maximum a little bit until I'm on the right side of the maximum. And then just hit enter for your guess. And then what you should see is the little flower or spider standing at the top of the hill, okay? And then you can read off the maximum from right here. So the maximum, the x coordinate is 1.414, and the y coordinate is 4. Okay, so let's see what it said again. It says, for what value of x is the area of the maximum? So the maximum area this thing can be is 4. This rectangle can be as 4, and the place that occurs is at 1.414 approximately. Okay, we're going to do about the same thing for letter D, and we're just going to graph the P of x and find the maximum perimeter. So let's do that. Just go to y equals and then just hit clear and then graph the P of x, which is 4x plus 2 square root 4 minus x squared. And then you'll have to hit enter. And then graph is the last button on the top. Okay. You get another kind of strange looking curve, probably even stranger, and it is also a restricted domain because it also has a square root in the problem. All right. Looks something like this, like a little hook. Okay, and the maximum that we're looking for looks like right about there. And remember, this time, this is the perimeter, and this is the x value. All right, so let's go ahead and find that maximum. Remember, second, calculate, and then maximum is 4. We have to go to the left of it, so let's scoot over a little bit. Okay, I'm definitely to the left of it, so hit enter. Keep hitting the right button until you know you're past it. See, I feel like I'm going back down right there. Look at the next thing that happens. If I go past x equals 2, y does not exist. I'm out of the domain, right? The largest x value you can put in is 2, so don't go too far. All right, but this one is good because it's a little bit less than 2, so it exists. And then hit enter. We'll see. Yeah, it went back up a little bit. So yeah, the maximum is at 1.789. So not right at the end, right? So this point would be 1.789, 8.944. So the largest perimeter you can have is the 8.944, and that occurs at x equals 1.789. All right.